All right, take two. Have we done this before? All right, so what you're going to do, you're going to run around back and forth and make him follow us. Okay, so take two. This is Have I Seen You Before? I'm Dan Reich. This is Max Pevzner. Max and I, we used to work together at a certain security product company, actually working on a SIM product. And we used to actually spend quite a few hours talking about, quite frankly, why customers aren't getting a lot of value out of this, how we're ingesting all this data, but quite frankly, the analysis portion is really, really difficult. SIM has a sort of an interesting background there and how it started. I'll talk about that in a second. But, we spent a lot of time trying to figure out ways of basically how we can make this basically work better for customers. And also for fun, we sort of tore apart some of the really interesting ideas that came by, such as the single node Hadoop guy. Yeah, it's still funny the second time I said this. So, anyways, so what we wanted to do, we had this idea for some time, and we finally decided, we're just going to go out and build this. We really wanted to focus on the solution that we could put together that wasn't really heavily loaded with math. There's a lot of talks that go on here using machine learning and other statistical methods to find data, and that's great if you have the background for it and you have the talent in your house. But quite frankly, I don't see a lot of companies really having that skill set in house or being able to retain the talent. So we were thinking about this from a different way of how do we get meaningful data. Something that's more useful and interesting without actually having to have a particularly strong background in math or algorithms. So that's what we sort of started working on. So before we get into what we built, right? SIM, the background of it, at least for me, the big driver for companies to buy it was really the compliance sort of story. We need to retain this data to show that we did these things, right? And it sort of morphed into, well, hey, I could also use it for my security operations center. I can create these rules, and these rules will tell me things like I have an executable downloaded followed by a Windows service installed, and okay, that's neat. It's useful from an operations perspective, but I guarantee you, it's probably not going to be very useful if you're trying to find somebody malicious moving across your network. It's just the tools aren't there. The data that you're collecting is really messy. It's not really normalized, and it's worse than finding a needle in a haystack. It's just a big mess, right? So we thought about different ways we could do that, and we came up with this idea around change, because ultimately, when you think about how when you're dealing with an infrastructure outage, first question you ask is, well, what changed, right? And that's very useful information to have immediately. And we don't quite have that when I think about SIM, right? How do I find things of that nature? So, basically, and that's the premise for this talk is, have I seen you before? So we wanted to build a tool that will simply be able to tell you, this is something you haven't seen before. And you think about the massive amounts of data. I know I've seen with some of the customers that I've interacted with back when I was working on the SIM product, when you're dealing with, how many terabytes?
Petabytes, sometimes.
It's just insane, right? And some of these places keep it forever, right? It's just way too much data. And, this is what it's like to work with a SIM today. So, not even Mike Rowe would like this job. So I don't like to generalize, because there are values in what you get out of a SIM product, right? But at the end of the day, I guarantee you, it's the successes that you're seeing in being able to find new malware and other things going through your network is probably slim. You're using a lot of other techniques to get there. It requires a lot of talent, manpower, lots of things that probably a lot of us don't have. And it's also probably not very cheap either. If anyone in the room has ever had to put together a budget, I'm sure you're probably trying to swap A for B to try to make things fit. So, the ground rules for what we decided to put together are we can't rely on a product that has to define everything that's bad in the world, right? We've done this many, many times over in our industry, right? Antivirus was probably one of the first products like that. You create a signature, you look for the signature. IDS, network access control, now we have application whitelisting, and they're not bad. They do what they're designed to do. But the reality is that we can't rely on them we can't depend on the vendor to define everything that's bad or good in the world, nor could we do that ourselves. So that was rule number one for the tool. We could not define everything in the universe. Second ground rule was you don't need a degree in math, because again, that's going to make it very hard for most people to consume. It needs to be simple and easy to use. So trying to avoid the math topic. If you do have that background, it's actually handy because you can better consume the output from this. And most importantly, it has to be efficient, cost-effective, meaning I can't consume your entire budget in infrastructure costs to deploy this. So that's it, Matt. So you want to talk about the architecture a little bit first?
All right. So can everybody hear me okay? Because I'm using a different mic. All right. So the first thing that happens in our architecture is ingestion. We are not going to replace your SIM. We are going to accept a data feed from your SIM. And your SIM is going to do a number of things. To some extent, it will normalize the data that comes in. If there are logs that come in, it will parse them. If your SIM consumes packets, then we will rely on your SIM to consume the packets, sessionize them at, say, application level of the protocol stack, or give you something a little bit higher level that we can consume. And there are a number of SIMs out there that will do a decent job at that, so we're not looking to replace them or displace them. This is technology that's already entrenched. A lot of organizations have them. No reason why we wouldn't use them. So the unfortunate part about this data that comes out of SIM is it's a monumental volume of data in many cases, which makes it very difficult to look at it and analyze it. So the first thing we're going to do is we're going to run a job that runs periodically. In our case, it's configurable. We run it every minute. We run it every 5 minutes. But it's going to go and it will aggregate the data. And we call this pre-aggregation. We'll get in a second why. So basically, if two hosts have talked to each other 20,000 times over the last minute, I probably don't care to see 20,000 messages. If I see one message that says host A, host B 20,000 times, that's probably going to be good enough for most cases. So that's why we do the pre-aggregation, and we do this pre-aggregation step early, so it shrinks the volume of data significantly, enabling us to analyze things we normally wouldn't be able to analyze. The next step is storage. Once we aggregated this data, we store it, so we make it available for future analysis. And in a later slide, we'll get into what technology we use to store it, and how we store it, and why we store it the way we store it. And ultimately, even if we aggregate everything at a 1 minute or a 5 minute interval, it's still going to be a fair amount of data. So we can have a post-aggregation step where we can do a hourly aggregation, a daily aggregation, weekly aggregation, monthly aggregation. We can do subject-oriented aggregations if we wanted to. So basically, the idea is that we keep constantly compacting this data as it comes in. Instead of storing all these, now we will still store all the events for compliance purposes.
Well,
so
not quite, but
yeah,
a little contention there.
Let's say you have your SIM system that stores these events for compliance purposes. Yes. So you will still have your events for compliance purposes stored in your SIM, but this is the system that will pre-aggregate them and will have them available for your analytics. We output this data, so we can generate logs, and you can feed these logs back into your system, into your SIM system, and leverage the alerting functionality that you have, so you don't need a whole separate dashboard or a whole separate setup for this. Use what you got. So how does it work in practice? Nuts and bolts. We're using a document database called Elasticsearch. And the data is represented in JSON documents. How many people here are familiar with Elasticsearch? Oh, good. So virtually everybody. Well, for the people who are not, I'll give you a quick rundown on what it is. The data is represented as JSON documents, so that makes it quite flexible. How many people are familiar with relational databases like MySQL, Postgres? Virtually everyone. So you guys know that the schema in your relational database is rather inflexible. You create your table. It has a set number of columns. The data types for your columns are set. And that's it. So Elasticsearch is quite a bit more flexible because you're storing a JSON document. And that makes it a much better fit for the SIM use case because the data that comes in that's parsed logs or parsed sessionized packets could quite a bit more variability to it. So if we look at dimensions that determine what is or isn't a big data problem, one of them is variety of the data and variability of it. So basically that's the redeeming quality of Elasticsearch that we're relying on, that it can cope with the different formats. The other thing that we rely on heavily is ability to do an efficient lookup by key. And that's not all document databases are good at that, but Elasticsearch is, which is very good and very useful. It supports aggregate queries. Not all NoSQL key value store or document database type systems support efficient aggregation. Elasticsearch does, which is largely the point for this particular system. And it supports advanced full-text search just because it's Elasticsearch and that's what it was originally designed to do, so that comes in handy in many different cases. It works through a REST API, so virtually any programming environment in widespread use today can work with it. So pick your favorite programming language, pick your favorite development environment. Chances are there are tools that are available to you that allow you to work with Elasticsearch. So as we said earlier, we have monumental piles of data that we deal with in the security use case and coming from a SIM system. So Elasticsearch is a distributed system that scales out horizontally. So if you want to scale your system, you add servers to it. You don't buy a bigger, larger server. So you're not limited by that upper bound of the largest server you can buy. You're limited literally by the budget, how many servers you can buy. And a lot of the systems that scale out horizontally require a lot of manual hand-holding and reconfiguration and puppetry and chef and various esoteric management techniques. Elasticsearch does not require any of that. It's well written in that growing up a cluster is very easy. You commission a node, you plug it in, it pretty much works. There isn't a lot of management pain that comes with it, so that's very good. Because we have a room full of security practitioners here, not database practitioners. We don't want to become database practitioners. We want to concentrate on the security use case. So one of the things that prevents systems from scaling to petabytes of data is their ability to fail over seamlessly and gracefully. So if you have to go and reconfigure something when a node falls over, that system will not work on petabyte scale. Elasticsearch will fail over gracefully, so it will largely take care of hardware failures and various issues that are inevitable at scale, because if you have 10,000 machines at any given point in time, at least a dozen of them will be down due to some hardware problem. And Elasticsearch does not require deep knowledge of the Elasticsearch engine and really sophisticated tuning techniques to make things happen. So again, this makes it a very good fit, in our opinion, for the security use case, because we're not looking to make you guys into database tuners and database practitioners. We're looking to give you a tool that can efficiently solve the problem without becoming a specialist in data management. So Elasticsearch, unfortunately, the database industry is plagued by terminology that's inconsistent even within the relational side of the house. So I'm going to give you a brief rundown of things that are comparable between Elasticsearch and the relational databases that most of the audience is familiar with. They are not the same, but they're close enough that they'd be worth comparing to each other, and that will give you a decent idea how the terminology maps. So index is a logical namespace for storing documents. So you store virtually everything you store in Elasticsearch. Pretty much everything is stored in indices. So it's different from what you are familiar with index and relational databases. An index points to multiple shards. So the actual physical units of storage where your data is stored that will be scattered across your cluster are called shards. So it's not unlike various other sharded systems. In relational databases, we have something called a schema. The unfortunate terminology thing with MySQL is that MySQL calls the schema and database as the same thing, which according to SQL standard, Postgres, and various other databases, it's not. So, if we use the standard terminology, an index in Elasticsearch is worth comparing to a schema in relational database. A type in Elasticsearch is worth comparing to a table in a relational database, or if we use the proper academic terminology, to a relation. It basically says what attributes your document will have, just like your table tells you what columns it have, your table definition. So a document is worth comparing to a record. They're not the same thing, but they have similarities between them that makes them, they're more or less in the same level as a concept. A field can be compared to a column or an attribute if we use the proper relational language. And a shard is very much like an extent in your MySQL or Oracle database. Now, we also have the equivalent of relational database indices in Elasticsearch, but they're called inverted indices because the regular index term is used for something else. So that's a brief rundown of Elasticsearch terminology. You know, if you keep this in mind, it's going to be pretty easy for you to understand any Elasticsearch speak. Pros and cons. Well, Elasticsearch is actually a bit of an overkill in that it works faster than we need it to for this particular use cases. It stores and retrieves documents in human perceptible real time. We're aggregating at a 5-minute or 1-minute interval. It's tunable, so it is faster than we need it to be, which is good. By default, every field has an inverted index. Think of it as something similar to a relational database index assigned to it. And that makes queries pretty fast. It seamlessly ages out obsolete data if you rigged it correctly, so you don't need to manually go and kill the old data. That can be just, if it's set up correctly, it will happen. And again, ease of management. We don't aspire to become database practitioners. We just need an effective tool that solves the problem. Elasticsearch, like any other technology, has its limitations. Out of the box, like a lot of the big data technology, it doesn't support authentication. So, but it's a solvable problem. You can put Elasticsearch somewhere in some environment that's controlled. There are solutions that will basically compartmentalize it and make control to that whole environment, support authentication and authorization, stuff like that.
Don't just go deploying Elasticsearch and expecting you to not have an issue here. I'm sure there's been a lot of other people talking about that, but
yeah, so
put it somewhere safe.
Yeah, don't make it accessible to the whole wild world. That's the point, but it can be made secure. There are solutions for that are available. So, well, I'm sure everybody here heard about data science. There's been a lot of talk. It's a very hot topic. So how does this Elasticsearch relate to the topic of data science? And what is, again, according to our rule, we're not doing any math. So I will explain in simple terms what data science is all about. My definition is a little unscientific, but it should give you most of it. So in essence, there are statistical learning and machine learning techniques that allow you to fish for a known pattern. Largely, there's something called supervised learning. That's what it's all about. You build a model, you train it to recognize a certain pattern. So basically, you grab some data, you manually classify it yourself. So a human or like a team of humans, basically, you tag things. And then you feed that data and you train your model to recognize that. And once your model is reasonably good at it, You start feeding new data into the same system, and it starts recognizing the same patterns in your new data. In essence, that's kind of it. There's a lot of math and a lot of different applications, but that's largely what data science is used for, that I see in the security use case. Not all security use cases are actually a good fit for this model, because searching for a known bad pattern is fine, but if you already know that something is bad, I mean, it makes it to a degree less labor intensive. Instead of eyeballing tens of thousands of lines of logs, you can have a system that finds this. But if something new happens, using this type of approach, you're not going to be terribly effective at finding that. If you just search for known pattern when something new happens, you won't find it. So that's why I'm saying that there are limitations in data science. And data science is a useful tool, and supervised learning is a useful tool that makes things less labor intensive, but there are limitations to what it can do. And one thing that I can't overemphasize is you must clean your data when you feed it to some data science algorithm. And that cleaning of the data is in many cases more labor intensive than applying the algorithm itself. And if you throw dirty data into your algorithm, data science is not magic. You're going to get a very dirty, noisy, and frankly not terribly useful result out of it. So there's something called overfitting that you may have heard of. In essence, every measurement that you have is going to have some error built into it. Overfitting means when you use your training set, you make your model fit your training set absolutely perfectly with no errors whatsoever. So now you have built into your pattern any and all noise that your training set has. So when you start applying a new set of data to it, it will search for not just the pattern in your training set, but also for the noise that was in it. And that's bad, and that's bad data science. Don't do that. So don't be overly precise. All of our measurements have built-in margin of error in them, and expect that. Don't do overfitting. It's bad data science. So compliments.
Sorry, I changed the slide on you.
Yeah, condiment. Well, think of it as a condiment. It complements and enables data science, this system that we're talking about. We calculate a very useful variable that you can feed to your data science algorithm or to your rules engine, or just look at yourself, that tells you that something is a new pattern. Something that hasn't happened before has just happened. So that enables you to catch things that are new. And the good thing about this variable is that it's very clear. It's easy to explain what it means, unlike a lot of machine learning techniques that are black box and something comes out of it and it suggests that something is bad. And why? I don't know why. You can use statistical learning as opposed to machine learning. Statistical learning techniques are slightly different in that they are generally explainable, whereas machine learning techniques are not easily explainable. So if you have your variables that are easily explainable and you use a statistical learning technique that's also easily explainable, the end result that comes out of it, you can explain why. You can solve the inference problem by saying, changing this does that. So basically you can say that I think that this is bad because it's new and these things happened. How good or bad is this new pattern? Well, that's where your data science and your risk scoring comes in, or your rules engine, or whatever technology you use. We're not going to tell you what's good or bad. We're going to tell you that something is new, and we'll let you decide however you want. We'll allow you to assess whether it's good or bad and decide for yourself. So the system allows you to clean up and normalize your input data, while the SIM systems, in some cases, do a decent job at cleaning up and normalizing your data. It's never perfect, and it never will be perfect because the logging formats will change and things will change, and you'll always get some amount of noise in your data coming out of your SIM system. And you have a somewhat limited feature set in your SIM system. There's that many things it can do, and that's about it. So here, by using the system, we allow you to go and change your data and further normalize it, however you want it. Further parse it, so things that are not available to you with built-in functionality of your SIM system will be available if you deploy something like this. You can derive useful variables from your input and then feed them to your rules engines, to your data science algorithms, or to your alerting system. And we store the data in a time series, so that enables any kind of analysis, really, that's useful, data science or not.
Okay, so I'm going to talk about what exactly we built here and how it's put together. So essentially, again, with the premise of we need to make this simple, we take a number of inputs that you will plug into the system. Basically, you define what meta fields you want to look at, plug them into a configuration file, plus a filter and an interval. This is kind of what it looks like. It's a little messy because it's still a work in progress. So pointed at your SIM, in this case we're using Elasticsearch as our SIM with Logstash, so we're just feeding logs in. Pointing at an index, in this case we're actually using Bro. If you haven't used Bro IDS, by the way, it's a really cool tool. So for purpose of the demo we're going to show you here, we're actually capturing our DNS activity and feeding it into Elasticsearch and then mining it as if it were a log. Again, you specify the meta fields. It can be 1 or 2. That's just a current limitation. In theory, we'll be able to expand that to allow multiple in this. So they're basically nested inside of each other. And then you specify filter. So we don't want to look at everything. In this case, we're going to be looking at query types of value 1. It's basically a record. So we're looking at here all the different hosts that are making hostname queries, the response back, and aggregating all that information together. So the other feature that we're working on still, there's still some issues with this, so we're hoping to be able to demo. It's not quite yet there, is what we do after the data, because it'd actually be kind of useful for us. If we're looking at just host names, I don't really necessarily want to look at all the new host names because there's a lot of new host names out there. I want to look at the domains, for example. So maybe I want to aggregate the host names into the domains and then pull those together because maybe I only want to track domains. Or maybe I want to be able to look at domains that have been created in the last 90 days. So we're adding in a series of basically nested host processing commands that you can actually attach to this, such as domain aggregation, IP to net block, and filters as well, so we can look at, for example, is this domain new? Has this domain recently been changed? So we're going to leverage whatever is out there that we can then further correlate, filter this data out. So we're squeezing this down to give you really rich, relevant data that you can look at. So what this kind of looks like, I know this is probably a little hard to see, but essentially, right, when you think about Elasticsearch queries, they're very messy, they're long, they're hard to get your head around. It's kind of a pain to put this together. So this is essentially what we boiled this down to in the case of how we're querying out of Elasticsearch and also how we're using it as our store for that stateful data. And so once we've done all that activity, we take the information, we've looked back at our state table, and we're going to compare it and then tell you basically what's new. So high-level view of what this looks like. So again, take the SIM, the tool. If someone has a better name, we're calling it SIMRI for SIM memory, but it's sort of sticking with me right now. We pull this information out of your SIM. We go through that process of aggregating, filtering, normalizing this down into something that we can then put into Elasticsearch as our state table, pull it back out at some point later to compare against, and then essentially we're creating a new log source, right? We're feeding this information back out through syslog. Within SIMRI, right, what this looks like is, again, pull the data out. As I said before, we're using it as our state table. So there's good and bad things about that, but at the end of the day, it actually works fairly well in terms of performance. So we're not actually having a lot of issues with querying data. So I'm going to kind of show you a quick demo of what we have. And as Max mentioned earlier, right, one of the nice things about Elasticsearch is okay. One of the nice things about Elasticsearch is that it sort of self-heals. So anyone here from Massachusetts, New England? All right. Do you see the storms that went through yesterday? Well, that had a little fun in my server environment. And this morning I realized I should have checked the servers last night instead of drinking. And I had to rebuild the indexes on my Elasticsearch. So I had a very interesting, fun morning. Yeah. So what I'm going to do here, I'm going to open the window and sure. Let me go back. This one bigger. How's that? Yeah. All right, I thought of everything else but that. Let's see, where do I set this in here? Is it in preferences? It's a long time since I've changed this. Let's see if I can just change this to one of the others. I didn't do anything. All right, anyone know how to change the Mac fonts? The Mac colors? Oh, it's for the next window? I'll just, yeah, how's that? Hey, all right. So, what I'm going to do, I just pulled up just some random feed of new domains. So just to kind of show how this is work. This actually will take more than a few seconds to actually show up. So I'm just going to do a lookup. Okay, so while we wait for that, I'm going to talk about how this is actually working in the background. So again, as I mentioned, I'm using Bro IDS to collect this information. So first Bro is going to pick it up, drop it off, then Logstash is going to come along, pick up that information, feed it into Elasticsearch. Elasticsearch is basically, I'm using it as my SIM in this case. It should work with other SIMs out there. I just don't have a license for a lot of these other products. I probably could have used Splunk, but I just started with Elasticsearch. So once it's in Elasticsearch, right now this is configured to run every minute because I don't want to wait for 5 minutes during a demo. And so once it's in there and then the job runs, it should spit out the information. Now, one thing I started to add in here with some of these, you can see the execution time here. So again, it's still recovering a little bit from the hiccup yesterday, but generally the query times are less than a second. So I'm going through all this data, and I've been running this for a while. So as I'm adding more data, I'm just continually growing my data set. So in theory, this should actually get slower and slower, and actually really hasn't, aside from the fact that it's dealing with a little bit of a recovery issue that I started about an hour ago. So we'll give it a second here, and let's see if that shows up. While we're waiting, any questions?
So it's a fundamental limitation in the query to Elasticsearch. So the portion of the logic it does the reduction says this was the unique thing effectively, and it's a query to Elasticsearch.
So it's done outside of Elasticsearch. So Elasticsearch is just pulling up the data that we're looking for. So it's not being done within, it's strictly being used as a database. So what it's doing, and did it pull it up yet? No, not yet. So the logic is basically based on the meta that you've defined, right? It's going to do a comparison to see if I've stored that previously. So in this case, I'm using the query itself, and I'm pulling down the relevant information that has occurred in the past. So when I get the new information from the SIM, this is what's happened in the past 1 minute or 5 minutes, whatever my interval is. It's pulling down all information, aggregating it together, and then it's going to mine that out of Elasticsearch to say, well, these are the domains that I've seen recently. Are any of those in Elasticsearch? And then within the tool, it's actually doing the logic there as to if I've reduced it down by domain or if I've grouped it into a network block, for example. It's all being done through a comparison, basically through an iterative loop.
How does it handle jobs that are iterative over, say, something that runs at midnight every night, or runs, Saturday afternoon, something like
is it materially different every time?
It shouldn't be that.
Then it wouldn't have a finding, because you can adjust how often you want to run this. So if you have a job, you want to monitor a particular environment, and you're looking for anything that might be net new from that output, you can set this to run once a week if you wanted to. It really comes down to what your requirements are for how quickly you need this information. So this is not going to be real time. We're not trying to build a real time tool here. The goal here is to be able to, and quite honestly, a lot of the data that you actually will get out of this is going to be, I'm not going to drop what I'm doing to go look at this. This is there to help complement what you're doing. So if you're already doing an active investigation, you're looking for things, there already is other indicator signs in your network. This is data that you have at your fingertips that you can look up, because you might have, the second job here actually is based on 2 fields, the query and the client that requested it. So if you have that as part of the job that's running, you can correlate that to the IP. So I'm already looking at something else going on with somebody's computer, and I have some interesting new activity that's also occurring. Or, for example, and in fact, actually, while we wait for this, or did it come out already? Let me see. No, I ran it remotely. So the demo gods are not being kind. Let me run another one, just to be certain. And some of these actually was testing earlier, so I may have just picked one I already ran. So I apologize. Okay. So hopefully that'll show up. So the way I envision that this would actually work is that you're going to be looking at your logs, looking at your high volume activity that normally you would basically not necessarily look at on a regular basis, just because it's high volume and there's way too many things flying by. This actually reduces it to presumably a smaller set. There's still going to be a lot of noise because there's going to be a lot of new things that occur. Yes?
So architecturally, if I understand, is you're essentially taking all logs and dumping it and BS queries to do the aggregation to build that. So what I see, which I understand, what I call the price effect, pretty powerful.
Right.
But as the downside, you have to replicate full logs in classes to have a solution essentially duplicate. Did you consider?
No, so actually, just for the purpose of the demo is what we're using Elasticsearch. In the plan is actually to connect this into other SIMs such as Splunk and pull your logs out of whatever SIM that you're currently using. As long as there's an API to hook from it, the way it's built is modular. So in the config file that we have, you specify the server type. Right now, we've implemented Elasticsearch. It could just as well be Splunk, ArcSight, Security Analytics. So whatever product you're using will be able to support it. It's just a matter of having access to those environments to actually do the integration work.
So similar to Python, you're actually aggregation of all to ArcSight and everything. So on that engine to do the
No, not necessarily.
So I guess not understanding architecture.
Sorry. So it's basically all we're doing is we're fetching data out of your SIM. There we go.
There you go. Yeah, so the architecture is basically your SIM system is going to parse say you have a raw log of something. Your SIM system is going to have a parser in it that will parse that log into its constituent elements and do some amount of normalizing them. Then what we do is we feed it to Elasticsearch in the base to our Python script in this case. It's a prototype. And it will go and use Elasticsearch as essentially a lookup table. So we're going to go and say, for this thing that just occurred, do I have it in my lookup table called Elasticsearch already? You could use other engines for that, or not. If I have it there in the lookup table, it ain't new. I've seen it before. So I'm going to just move on. If it's not there, I'm going to park it there, saying it's new, and this is the first time I saw it, and the count is 1. And I'm going to go and send a syslog message saying, this thing just came in, and it's new. I have never seen it before. So this is, in essence, at a high level of the architecture of the system.
I guess where I'm going down is you can have two choices as far as how to get most of it. You can take a full feed out of your SIM, or maybe every which is going to provide on, or rely upon the SIM to do that aggregation for you say, what's new, in which case, why not just work with the SIM directly?
Well, the SIM is going to be able to keep that stateful information, tell you that this is net new over, say, a year. So if I'm going to look at information I've had over, I'm sorry? Well, maybe someone can. Spill the beans. Which product?
They all. I haven't got some.
Well, the thing is that traditional, and since we both worked on the SIM environment, I mean, you can try to rig a SIM to do this kind of lookup of what's new. However, typical back-end technologies that a typical garden variety SIM uses today are not terribly scalable. Their backends are usually a couple of decades behind the state of the art in the world that we call big data. So yes, you can try to do this lookup functionality inside your SIM. It will most likely be very painful. I can't speak for all SIM products, but the SIM products, and I'm not going to do any vendor bashing, but the SIM products that I have worked on and that I'm familiar with generally have a difficult time of doing this type of what's new lookup because of the back-end technology that's built into them being kind of old school, if you will. So we are basically adding this module here that enables technically, if you look at their product sheets, yeah, technically they can do it. The problem is once you start pushing volume of data,
it's going to fall over.
They're going to fall over. This thing won't fall over because the database technology, if you will, that we're using here is state-of-the-art big data technology. And not all big data technology is created equal. You may have heard of this thing called Hadoop. And it's a wonderful system if you're Facebook. I've worked for Facebook before. If you are Facebook and you can afford 16,000 servers and your core business is about analyzing what's going on in your social network and monetizing it somehow, and you throw really thick wads of cash at this problem, yeah, Hadoop's a great tool. The budget of your security organization is not going to make a 16,000 node Hadoop cluster available to you. And Hadoop really, really, really is very bad at scaling down. You really shouldn't be contemplating Hadoop if you're going to have less than 500 nodes. Who here has a budget for 500 enterprise servers for your SIM system? Didn't think so. So that's why Hadoop and Hadoop-like systems, while they're great for what they were designed to do, they don't really apply to the security use case. Elasticsearch has the advantage that not only does it scale up, it will actually scale down and it will be relatively inexpensive to run on the low end of the scale. But even though it will be relatively inexpensive to run at the low end of the scale, it will perform better than most SIM system backends that I'm familiar with.
MSQL? Yes.
Yeah, we have considered simple key value stores, but generally simple key value stores have problems with scaling out. They don't auto-shard. You have to manually do that, script that, do all kinds of puppetry and chef. And you guys should really concentrate on solving security problems, not building scale-out systems. Trust me on this, I've built scale-out systems. It's painful. It requires a fair amount of time and talent. And it's just time-consuming. So also simple key value store type systems don't really run aggregate queries. Most of them are a one-trick pony. You plug something in by key and you grab it out of there by key, and that's the extent of what the system does. So, Elasticsearch has that nice feature set where it does the things that we need from the store. It runs aggregate queries, it does lookups, it scales down, it scales up, and it does all these things seamlessly without me having to go and run. Because I've run large Hadoop clusters before. It's a ginormous pain in the neck. Generally, in a larger organization, I have a team of engineers that run the Hadoop cluster, make sure it's up, everything is fine and dandy. Now, who is going to hire a team of Hadoop engineers to run their SIM?
I think he has one.
Yeah. we found, a certain vendor has found out the hard way that that's the case.
Okay. So I know how many minutes do we have left? Okay. So what I wanted to do this will advance, there we go, is have a little bit of interactive part to this. So the demo that I showed you, again, this is really early code. We were actually hoping to be further along. We had a few setbacks along the way, but we built the demo using DNS queries. In theory, you could actually work on anything that you could point it at in your environment. So point it at your Splunk, pull out DNS, right? We thought about a few other sort of scenarios, right? I talked about where the domain is fairly new. Again, if I've reduced the set of, here's a new host query or domain that I've seen, then I can actually I could afford to go out and do the appropriate queries to find out when this domain is registered without actually creating a massive delay. We could also look at things that are basically non-host record, reverse record lookups that may not be common in your environment, so we could pull those out. Other thoughts we had around this are using it with your NetFlow information, because again, NetFlow is good for performance, but how do you actually mine this for security purposes? So if I want to actually map out my infrastructure and look who's talking to who, if I suddenly see a huge uptick in new host names, host AD connections, that could be an indicator of something I don't want in my environment. Maybe it's lateral movement, right? Port knocking, right? We can look at that, all the various new ports that I'm seeing being connected to. Or, again, an uptick based on the host. So I can tier these and I can say, not only looking at host A to B, but host A to B and the ports that they're using. So what I wanted to do now was really kind of get some audience participation about, well, this is what we thought about putting together, but BSides is all about interacting and having audience participation. So I'd like to get your thoughts as to where we should go with this, if it's useful, first of all, and is this something you could use in your environment? And to sweeten the offer here, we brought along, I know it's early, but it's 5 o'clock somewhere. So contribute and have a drink with us. Go ahead. Mm-hmm.
Somebody sending something out, is it to a new domain, or is it to that address, or it's only for us to work?
That would certainly do that. Come on up and have a drink with us. Along that note, one of the other thoughts I've had, I just haven't, I didn't put it up on the deck here, was basically looking at the emails coming in. I could look at the sending domains and extract out the URLs that are coming in. So I could look at who's sending me email and also look at the embedded URLs in there to see if I have new domains or new links that I haven't seen before. Similarly, I could also look at where the emails are coming from. So look at again, I spent a lot of time using Bro, which is really cool if you want to prototype this and get a lot of information that you're not going to get out of a log. So looking at where the email's coming from, not only the sending domain, but the IP hops that it's taking to get to me, and monitoring if there's changes in that activity. So I'm suddenly, if I'm thinking about critical partners that I work with, and these are the emails that I have to be getting because I work with other organizations, and looking at the source IPs and all the hops that it's taking, if I start to see changes in that activity, maybe that's something I want to pay closer attention to. Right.
That's a really hard problem for us.
Correct. You're going to have a lot of findings. And the point is that this information will be at your fingertips when you're doing other investigations, or you're looking, or if you have free time. There may be things that you, yeah, I know. Well, some of us don't eat lunch. But if you were to take this and do this type of query in Splunk, right, after an incident has occurred, how long is that going to take to run? To find when was the last time I saw this? What is the frequency that I see this? If you're going to try and pull that information out of Splunk, and I want to go back over 30 days, 90 days, or a year, how long does that query take? Or pick a SIM. They're all going to have you know, from my experience in working with different products, they're all going to be very painful.
Yeah, Lee?
If someone else has solved this, I'd love to hear about it. I'm sure everyone in the room would love it. Yeah, we're not blocking this because, again, if we have this information and if we're assuming that we know this is bad, then we should be blocking it, because me telling you that this is something that's bad, you should be blocking it, not simply telling you, yeah, this bad thing just occurred and now you're hosed.
New host any new DNS query has anything connected to it every day since. It's really brought the amount of data to something now. Because I did try like everything. Yeah, it was even too much for like, hey, insert like read that report. But once we did that, I was just like, well, okay, here's still a fair amount that you could kind of eyeball it.
Yeah, so it will help you prioritize what you want to look at first, what you want to look at last. Because the challenge that we see a lot with a SIM system is that there is a sea of warnings that you want to look at. And if you add this system to it, you say, yes, you have 10,000 things you want to look at, well, maybe you should look at these 5 first. Oh. Good one.
That's a great one.
That's a great one. Come on here.
Come on down. All right, I'll take a shot for you. All right. Yeah. So oddly enough, yeah, I've looked at using Havana to visualize this. Interesting interface. I just had too many issues trying to massage the data to get it. Kibana is very powerful, but it's also, at least for me, it's a little, I tend to think in a different way. So I had a hard time visualizing some of this, and so I focused on getting this to actually function as opposed to getting the visual aspects of it. But certainly there's a lot more that we want to do with this, and we'd love to have input, and if folks want to help out, we'd love to have help too. I think this would be useful, at least from my background experience. I think I would certainly run this at home just to tell me what's going on in my environment. Anyone else? I think we're out of time here. Yeah. Absolutely, it certainly could work that way. The intent of this is actually feed this back into whatever SIM you're using, because you want to have that information at your fingertips, so that as you're doing an investigation, you can pivot off of key information like IP address or username, etc. So we'll feed that information back, and you should be using it as, you know, you can use it with pretty much any rule engine that you have, no matter what SIM product. They should be able to digest this and work with this to actually have more intelligent responses and reprioritize what is coming in.
Yeah, the thing about is that depends on what format this data comes in. If it's in a log format, then you would want first for something to parse that log, because you shouldn't really be throwing like entire log lines into Elasticsearch. You won't like it. What you want to do is you want to have something that can parse them, and yeah. I mean, there are a number of open source systems that you could provision for this. Like Bro is not a bad system to use. Yeah, so once the data is parsed and basically it's not a line of text, but it's a bunch of attributes, you can throw it in Elasticsearch, pre-aggregate it, then feed it to your SIM. And this is basically, if your SIM installation is not able to cope with a large volume of data, you can pre-aggregate it. So basically, instead of putting the system after the SIM, you can put it before the SIM, but the data that comes in has to be consumable by Elasticsearch.
So we're getting video out here. Why don't we take this conversation out to the hallway? I'd love to share this forward. That's okay with everyone.
All right.